Alrighty, so it's 9 o'clock, and if you were at Zoom last night, then you know we talked about how to prepare for the test. And if you weren't at Zoom last night, I edited and uploaded it. Nobody's looked at it yet, but that may be because people didn't expect it to be up already. But you definitely want to take a look at that conversation. So, are there any questions at this moment about the exam? I think it opened up this morning and it's due Tuesday at midnight. You get an hour to do it. It's really important that you are prepared in that hour, that you have the tools you need right in front of you, and that you don't waste time by looking through your notes or looking in the book, and that you don't cheat by communicating with others and looking things up online. Is it all multiple choice? No. There's a matching, there might be 3 matchings, a lot of multiple choice, and then 2 upload a file. And the last 2 questions, question 19 and 20, which are upload a file that shows your work, those are worth 24 points. So I would say that's a huge chunk of the test. Other questions?
For those of us who take like notes on a tablet, I use GoodNotes. Would you be okay with us like scanning through those?
They're your handwritten notes?
Yes, everything.
That's fine.
Okay.
Yeah, any work that you have done is fine. Like this would be considered, again, how do I monitor this? You're on your honor. Eventually, cheating shows. I already had one experience this week where I was grading and I went, what? This work, this answer, they don't match. Like, it's easier in a classroom when you can watch people. All the tells are, you know, in the way they hold their body and how often they look at you during a test. But it's real. I mean, you can see cheating eventually, but eventually it plays out and it sorts out. So let me tell you what I think is okay and what is not okay, and then you'll make your own decisions, and I hope you make good choices. So if you have handwritten the notes, you've done the work of sifting through all the information, organizing your thoughts, and writing those notes. And in a way, that's studying. And then what you're relying on during the test is work you've done. So that's totally fine. If somebody was to make a summary sheet of notes and then give it to a group of friends, that's cheating, because if you hand your learning to someone else so that they can feed off of it during a test, that's not their work on the test, you know? Also, the reason there's reasons that's not good. And one of the reasons is then they didn't learn. The process of sorting through the information to figure out what is important, like to create the connections in your brain and then the hierarchies, allows you to retain information so that you can use it next semester and the semester after. That's where real learning happens. So yeah, Marilyn, that'd be fine. Other questions? Okay. So if you have your phone or device handy, we're gonna do a couple Kahoots. So go ahead and pull that out. Here we go. Good job. All righty. That was really interesting for me. Do you have any questions? Oh, I'm sorry, Josiah, that the phone is not cooperating. Sometimes I love technology and sometimes I don't.
What are mothballs made of?
They're made, there's two different things. One's paradichlorobenzene and another one is naphthalene. Basically, it's a solid that sublimes. And when it sublimes, it now is in the air where the insects are, and it's toxic to them. It's also toxic to humans, but insects can handle a lot less than we can. So it kills the insects. Other questions? Okay, so as I was watching that and a little bit surprised at some of the results, I started thinking, okay, if I were a student and I just got this information, what would I do? And so there's two things I want to do. One is to remind you about physical and chemical changes and properties, like what the important question is. And then the other is to remind you or maybe suggest an idea for studying that might be helpful and you definitely want to have as you take the exam. So I would sift through your notes, books, and videos and make a list. It is not cheating, it is called studying. If you start at the beginning of the class and you work through the material, and then as you see the material, you kind of mark it in your mind as, oh, I already know that, or I sort of know it, let me just write it down so I can learn it better and so I have it available on the test. So maybe there's two ideas. One is changes, so physical or chemical. And now I'm talking about changes. And then just every example that you have, you can put either here or there. And the big idea is, did the smallest unit change? Did the smallest unit, so the molecule or the compound or the elements, whatever is the smallest unit, which we haven't gone completely into, but you do have an idea of, change what it is? And if it did change what it is, if the answer is yes, that's chemical. And if the answer is no, that's physical. I think you'll remember there are two kinds of physical change. One is change of state. And there are 6 change of state words. What is a state? The states are solid, liquid, gas, and aqueous. And so for solid, liquid, and gas, if it goes from solid to liquid, that's fusion. From liquid to solid, that's freezing. Fusion and freezing are change of state words. And they're going to help you know that what happened was where the smallest unit is changed. Maybe it was locked into a 3-dimensional structure like an ice cube, but then you heated it and now it's spread out, so they're farther apart. But water is still water before and after it melts. So change of state is a change in where the smallest unit is, but not what it is. And then the other kind is mixing and unmixing. So mixing might be, sugar dissolves in water. And you could evaporate the water and get the sugar back. So those are some words that you need to recognize. And then the examples that I've given throughout the semester, those are the examples that I'm going to use on the test. I'm not going to pick something that I don't think is fair game. So fair game to me is I know that I have either put it on a video, it's in your text, or I've said it, or it's on a worksheet. And then if you haven't watched the videos or done the worksheets, so you're not familiar with like maybe mothballs or iodine subliming or dry ice subliming, those are all examples of solid goes to gas, then that's because you didn't do what you needed to do as a student, which is to go through all the material. But I'm going to pick examples that I think are fair game. So I'm not trying to trick anybody. I'm just trying to test, do you really know, did you learn things? Okay, so a physical change, and at any point, feel free to chat or just speak. It's fine if you just talk to me. In fact, I love it when you talk to me because then I don't feel quite so alone. A chemical change is a change in what something is. And so there's going to be words like, when you hear combust, that means this thing just lit on fire. The smallest unit changed. If butane combusts, it was butane before, and afterward it's carbon dioxide and water. If paper is flammable, it was paper before, cellulose, and now it's just carbon dioxide and water. So combust is a word that would tell you this is chemical. There are a lot of chemical changes. If you heat water, liquid water becomes gas. That's a physical change, water before, water after. But if you pour acid on metal, many metals bubble. Those bubbles are chemical because now you're making hydrogen gas. And you didn't start with hydrogen gas, so that's chemical change. Okay, so those are changes. Does anybody have any comments or questions? And then the other one would be properties. Oops. So property is just a descriptor, how we describe something. And properties can also be physical or chemical. So it's basically the same idea. In determining this property, did the smallest unit change? And if the answer is yes, it's chemical. Or could the smallest unit have changed? So can I know the freezing point of water? Sure. I start with liquid water. I put a thermometer in. I stick it in the freezer. And I notice the temperature at which the liquid becomes solid. That's the freezing point. But it's water before and water after. So melting point, the temperature it melts at. And freezing point is the same idea. The temperature it freezes at does happen at the same time or same temperature. That is a physical property. I can know it, and the smallest unit didn't change. Flammability is chemical. If I have paper before and it burns, then I don't have paper after. This is a little weird. Not being flammable is also chemical, because if the property is chemical, the unproperty, the not doing it, is chemical too. And where are you going to see that? These notes are horrible. I hope you're writing better notes where you are. And where would you probably see that? A great example is like acid reactivity. So many metals, most metals, are acid reactive. If you pour muriatic acid, is what you put in your pool to clean it, like to kill things. It's also known as hydrochloric acid. If you put hydrochloric acid on zinc, it's going to bubble. It's going to make hydrogen gas because zinc is acid reactive. If you put that same acid on magnesium, calcium, just pick any metal. Most metals, that's going to happen. So acid reactivity leads to hydrogen gas production, and that is a chemical property. But it doesn't on the money metals. Gold, silver, zinc. Oh no, I said that wrong. Gold, silver, copper don't react. So being inert, not reacting, is the opposite. Acid reactivity would be chemical, and not reacting would also be chemical. Because if the answer was yes, change could happen, the change would be a chemical change. So comb through your stuff and make a list. And if before the class you get together with some people that you've met in Zooms and discussions, and you compare lists, that's not cheating. Comparing during the test, that would be cheating. Comparing after the test, like one person's taken it and the other person hasn't, that would be cheating. But preparing before is preparing. Okay, if there are no questions, we're going to do another Kahoots. And this one's on sig figs, because I know that is important and sometimes difficult.
I was just saying that I think Kahoots is pretty good because they get instant feedback.
Yeah, totally. I will try to make more Kahoots. Okay. Okay, so this one is on sig figs. How many sig figs does this value have? 8.00 centimeters. The answer is 3. Zeros behind decimals in a digit, they do count. How many sig figs does this value have? 4.8 units, measured with ruler A. Good. Same value measured with ruler B, 4.80. On the line. So that 0 means on the line, 4.80. The 0 is to the right of decimals and a digit. It's significant. How many sig figs does this value have? 18.9 milliliters. Good, 3 sig figs. How many sig figs does this value have? 20.9 milliliters. So that 64.0 milliliters, 0.0 means it was estimated to be on the line, and it's significant. So both values went to the tens place, and when you add and subtract, the number can go as far right as both values go. So to the tens place, that 0 is significant. You see this reported value, 0.020 grams. How many sig figs are given? So the 0 to the left, before and after the decimals, those aren't significant. The one between the decimal and the number 2 is a placeholder, keeping the 2 in the hundredths place. But the 0 after the 2 and the decimal is significant.
Oh no.
Melissa, what happened?
I didn't see the one on the bottom. I guess I'm trying to go fast because I'm in 13th and I got everything right. It's just because I'm not going fast enough. So I got super competitive and then.
Oh dear. Oh dear. Okay. You see this reported value, 5 coins. How many sig figs are given? And the answer is unlimited because you can count coins. They're discrete, meaning a whole unit that doesn't break into little pieces. They're small, it's a small number. 5 is not too high to count. And you can count with, they're not moving fast. You can count with certainty and know. So unlimited is exact. How do you know it's exact? You look at the units. If the units are things that you measure, we count sig figs. If the units show that it's been counted or defined, we say unlimited. So 1,000 millimeters per meter came from a definition. 1,000 millimeters equals 1 meter. So that is a conversion that is unlimited because it's exact, because it came from a definition. You can choose more than one option. Okay. Oops. Are the questions on the test going to be in a similar format? There won't be any music, but a lot of them will be multiple choice. That's true.
I have a question. One thing that trips me up is the instrument you're using, but that in reality, does it have nothing to do with how many sig figs you can get?
It does. And then there was some object, and it was some length. And then for ruler A, maybe it had just, divisions like that. And then ruler B had the same divisions, plus it had things broken down. Pretend that there's 9 lines there. And so with ruler A, you've got the ones, and you're estimating the hundredths. I'm going to call that 1.6 units. And with ruler B, you have the ones and the tenths, and this one you're measuring the ones and the tenths. I said hundredths, I think. And this one you're measuring the ones and tenths, and you're estimating the hundredths. And so even though these may be giving you the same measurement, sort of, 1.6, more divisions, the tool determines how far to the right the number can go. And that's half of sig figs. The other half would be how large the object is. The object determines, how many digits to the left there are. So if we had something that was a lot longer, not to scale, it might be 11.2 or 11.20 units, depending on, was it measured with A or with B? And so now, because the object was larger, we gained in the tens place. The tool measures the tens, ones, and then for ruler B, it measured the tenths, and we estimated the hundredths. So the number of sig figs depends both on the tool, how far to the right do we measure, where's the estimated digit, and the object, how large is it. Does that answer your question?
It does, thank you. The other thing that I found a little confusing is within a system, I forgot what problem I was working out, but it seemed to be that even though I was doing within a system, I still had to report less sig figs. And it was when I was working out that video that you had done.
I've done a lot of videos. I need you to be more specific.
The one that was on sig figs specifically, it was an hour long. The unit conversion one.
Okay.
Mm-hmm.
Within a system, and it limited the sig figs. That doesn't sound right. If there was a rate or a density somewhere along the train tracks, that would limit the sig figs.
Okay.
Okay. I can look at that when we're done today, and maybe I'll just text you and say, is it this one? And then we could talk about it.
Okay.
Or if you find it, you tell me, and then we'll talk about it.
I'll go ahead and look for it.
Okay, that'd be great. Thanks. Okay, other questions or comments? Alrighty, so being able to report sig figs is something is where we start. And when you report sig figs, you have to decide, is this thing measured or exact? And then based on some rules we learn about how we report things, when we read other people's stuff, we look at the units to decide, is it measured or exact? And so measured would be something, a physical quantity. And in our class, we measure mass, and we would know by the units would be grams. Length, the base unit would be meters. Volume, the base unit is liters. Even though we don't actually measure in liters, we typically measure in milliliters. And then of course there's temperature and time. So somebody asked last night, are we going to have temperature conversions on the exam? You know, degree Fahrenheit to degree Celsius to Kelvin? And the answer is no. It's something you need to be able to do, and we'll be doing more of that in the semester, but I haven't put that on the exam. Okay, so if you see something, if you measure something, you measure every digit you can, and you estimate the last digit, and then you report it. Exact would be counted or defined. What can you count? Things that are large enough and discrete and not moving and not too many, you can know with no uncertainty. What kind of units might you have? Maybe coins or students. I'm not going to put cookies there because sometimes cookies break. But students don't typically have like a foot fall off, you know. You're going to have a whole student per student. Like every student is one student. What else could you have? I don't know, anything, eggs. Anything that is whole, discrete, not moving very fast, and you can count. And then defined is going to come up in our class a lot. Oops. So definitions would be things like 2.54 centimeters is an inch. That's the only one that between systems is unlimited. The other ones that would be between systems, so for volume, we might be going from quarts to liters. That has limited sig figs, and the value that you're to use is the one on the conversion sheet, which is 1.057 quarts per liter, 4 sig figs. And then for mass, we sometimes pretend that pounds are a mass unit, not a force unit. And so you can use the one on the conversion sheet that is 2.205 pounds per kilogram, and that has 4 sig figs. For length, it's amazing that we have this one that is unlimited. Within system, things are defined. So 12 inches is a foot, unlimited sig figs. 100 centimeters is a meter, unlimited sig figs. So if you were given a set of problems and they look like this, and you had to decide how many sig figs, you would start by classifying. And how do you classify? Measured or exact, you look at the units. So for the first one, the units are centimeters. That's something we measure. I should be able to count the sig figs. But the problem is it's ambiguous. It's a whole number ending in 0. And yes, ambiguous and exact will be some of the possible answers on the multiple choice portion of the test. For the second one, I would say unlimited, because it came from a definition. How about the third one?
Exact counted.
Well, normally it would be exact, except it's a whole number ending in 0. So that one's a bad question. I won't ask it. How about the fourth one? Okay, and now once we have numbers, we're going to have to do math on them, and there's 2 rules, and the rules are the adding subtracting rule and the multiplying dividing rule. There are only 2 rules, and they're always the same, but for some reason this confounds students. So can I erase this page? No objections cited. Okay, so handling sig figs. There is the multiply divide rule. And that would be count the number of sig figs. Use smallest number. So if I start with something that was measured and had 3 sig figs, and then I multiplied it by a conversion that was unlimited and unlimited and unlimited, my answer would have 3 sig figs, because 3 is fewer than as many as I want, or infinite. But if I had something in the middle that was a limited conversion factor, and so that could be a rate or a density, now I have to consider the sig figs, because those aren't unlimited, because those came from measured things. So if here, maybe I had something with 2 sig figs, my answer would be limited to 2 sig figs. The one rule is the adding and subtracting, the multiplying and dividing rule. And the other one is adding and subtracting. And so far in our class, there's pretty much 2 times we do that. One is we're going to add to get to degrees Celsius to Kelvin. And the other is we're going to subtract to find volumes by displacement. And so the first one would be, I measure the temperature in here, and it's 23.5 degrees Celsius. But what I really need is a temperature in Kelvin, because sometimes in science we need an absolute scale where there's no negative numbers and the temperature can't be 0. And so I add 273.15 . Now, the number on the top went to the tens place. I don't know what's in the hundreds place. So when I add these together, even though it looks like in school we would say, well, 0 plus 5 equals 5, it's not 0. I just don't know what, it could be 0. There's a 1 in 10 chance that that number is 0, but I don't know what that number is. So I'm going to put a 5 here because my calculator told me that, but I don't know that place. The hundreds place is unknown to me. Okay, so this would be a 6, 6, 9, 2. This is the last place that we know. For adding and subtracting, we can only go as far right as both numbers go. They both go to the tenths, and then this number goes to the hundredths. I can use it on my calculator, but I don't really know what's in the hundredths place. So I look to the right and I decide how to round, and you might round to even, or you might say 5s round up, and I'll find either way. Oops. And that number has 4 sig figs. The measured item had 3 sig figs, but we gained on the left. When you add and you're adding and subtracting, you can gain on the left. And then the other time we might see it is for subtracting, because we want to find volume by displacement. So that's, we had a graduated cylinder and it had some water in it. And then we put an object in a graduated cylinder, and the object pushed some of the water out of the way. And we subtract those 2 volumes, and whatever the difference is was the volume of the object, which is called volume by displacement. So now I might have 27.6 milliliters is my final, but I started at 22.4 milliliters. That was my initial. What is the volume? When I'm subtracting, I can lose on the left. Both go to the tenths place, so I'm confident that that's a 0.2. So I started with measured values that had 3 sig figs, but my answer will only have 2, because when you subtract, you can lose on the left.
I think you clarified my question earlier about, because I did have a definition, so that was confusing me, but because we were going from one system to the other, it wasn't an exact unlimited conversion.
Good.
Thank you.
You're welcome. Other questions?